Explorer is sending back alarming information to Earth. The Explorer 1, NASA's farthest voyaged shuttle, is as yet voyaging across unseen districts of the universe almost 50 years after its send-off. Researchers are confused by the frightening information that this well-known space test machine is sending back to Earth because of what gives off an impression of being a glitch. Join us as we discuss the odd information that the Explorer has been sending back to Earth during its irritated space investigation. Venture researchers have been intrigued in finding out about the domain's past since the Big Bang, and that is what enlivened the send-off of the Explorer 1 and Explorer 2, among other space missions. The Explorer 2 was actually the first space apparatus to launch, withdrawing from the NASA Kennedy Space Center on August 21, 1977. On September 5th of that very year, Explorer 1 was sent off about 14 days later. Anyway, how could they switch places as twins? The heaviness of the two tests is 720 kilos, roughly equivalent to a little vehicle. The two of them were sent off during a window of unique out-of-planet arrangements that causes a slingshot impact to launch the shuttle from one planet to another. They have, however, had to move at different paces and in different directions. On December 15, 1977, the Explorer 1 had the option to pass its indistinguishable twin along these lines, and since it has been our go-to asset for finding out about different realities in space-related conundrums. The primary rocket to do so was this one. When it started its Jovian imaging mission in 1978, it was around 265 million kilometers from our planet and sent a huge measure of photos back to us. The Explorer 1 finished a remarkable 100-hour spell starting in January 1979, during which it caught 3,750 pictures of Jupiter's rotation to produce a time-lapse film showing 10 of the planet's turns. It had gone through the Jovian moon framework in February 1979, and after a month it had seen the little ring encompassing Jupiter. Explorer 1 likewise made a remarkable revelation when it found two new moons named Steele and Meitei. Remedial moves would be made to guarantee that the space apparatus was prepared for its flyby of Saturn, and to forestall a potential crash with Titan, one of Saturn's moons. Explorer 1 additionally discovered 4 different moons during its orbit of Saturn, including Mimas, Enceladus, and Dione. Our researchers chose to stop the Explorer planetary mission after the Saturn mission was completed and sent both Explorer 1 and Explorer 2 beyond our planetary group at a speed of 325 million kilometers each year. In January 1990, the new mission, formerly known as the Explorer Interstellar Mission, got in progress. The absolute most popular photos in history, depicting the Sun and most of the planets, were taken by Explorer 1 on February 14, 1990, while it was 6 billion kilometers from the Sun. They are habitually alluded to as the Planetary Group Family Photograph. There were 60 complete shots taken by Explorer 1, bringing the total number of photographs taken by the shuttle to 670. Regardless of the way that Mercury and Mars shouldn't be visible in the photographs because of multiple factors, eventually, the rocket's cameras were turned down to moderate power and memory before its excursion to interstellar space. Also, to the interstellar tests Explorer 1 and Explorer 2, NASA additionally operated the Trailblazer 10, Trailblazer 11, and New Horizon rocket. Before Explorer 1, passing by the Trailblazer 10 on February 17, 1998, the Trailblazer 10 was the furthest rocket. Explorer 1 continued its excursion for a further 14 years before it finally arrived in the interstellar climate on August 25, 2012, with no other space tests in sight to find yet. NASA didn't publicly declare the achievement until 2013. Let's go to November of 2018. Both space tests have formally left the planetary group. When Explorer 2 crossed the heliopause and entered the interstellar medium, Explorer 1 was reported to be 145 billion kilometers or 1,550 Australian dollars from Earth. It has continued to provide us with significant data that no other space test missions have been able to unveil since it entered the unseen domain past our solar system. The spaceship has spent the majority of its 45-year trip in space in great health. However, lately specialists have discovered a few odd peculiarities in its presentation. Explorer 1 is now sending mysterious signs back to Earth, giving the impression that it is uncertain of its location coordinates. However, there is a frightening turn to the issue. Typically, researchers have pre-programmed Explorer to go into protected mode or sound an alarm in the event that it becomes lost in space. Yet, Up until this point, its antenna, which sends information back to Earth, appears to be in great working order. However, the information it has recently been communicating is dubious. The interstellar Voyager is working routinely, taking instructions from Earth and carrying them out, as well as gathering and communicating scientific data. However, readouts from the test's verbalization and control systems don't precisely reflect what is occurring inside. According to a NASA official statement, what exactly is happening on board then? Each rocket that is going towards interstellar space, including the Explorer 1 and 2, has an exceptional 12-inch wide gold-plated disc that is loaded with sound and video messages as a backup in case an extraterrestrial species finds the spacecraft. 35 Earth sounds, 115 live photographs, 90 minutes of Western music, and good tidings from former U.S. President Jimmy Carter, as well as former UN Secretary General Kurt Waldheim, are only a couple of the items on the space DVD. Moreover, they are kept in 55 unique languages, so if it was taken over by extraterrestrials, they would probably be trying to decipher the signals. Considerations that the spaceship is now under the direction of extraterrestrials have been quickly invalidated by researchers. Explorer's capacity to work depends intensely on the data's attitude and communication control system. For starters, it generally keeps its antenna focused on Earth so researchers can accurately receive information. Moreover, it controls how the spaceship is oriented. Engineers watching out for the situation now feel that the antenna is working as it should, which simply adds to the puzzle we already face. None of the safety features intended to safeguard the rocket from danger have been activated by Susan D., task manager for Explorer 1. A mystery like this is not unusual at this stage in the Explorer mission. The shuttles are both around 45 years old, which is a lot older than what was conceived in the mission plan. Susan D. also recognizes that the rocket's engineering team will experience some significant troubles in solving the issue with Explorer 1 due to the distance between us and the space test. The difficulties are imposing, generally because of the shuttle being around 145 billion miles from Earth. This tremendous distance presents a few complications that the team must explore cautiously. A salvage operation is almost unthinkable given the current technological and logistical constraints. Explorer 1 is a long way past the reach of any spacecraft or repair mission that we could possibly send. The spacecraft's amazing journey has brought it into the furthest regions of our solar system and beyond into interstellar space, where it continues to travel further away from us every day. Messages sent from Earth at the speed of light require nearly 21 hours to reach Explorer 1's current location. This means that any command or guidance sent by the engineering team takes a significant amount of time to be received by the spacecraft. This delay poses a significant challenge for ongoing problem-solving and troubleshooting. Moreover, once Explorer 1 processes the command, any response or data it sends back to Earth will take an additional 21 hours to return. This means that two-way communication between Earth and the spacecraft takes an average of 2 days. Such a delay makes it extraordinarily challenging to implement timely solutions or iterative troubleshooting processes, which are often crucial when dealing with complex technical issues. The engineering team must carefully design and execute each command, anticipating various scenarios and potential outcomes. Unlike missions closer to Earth, where engineers can quickly send and receive commands, the long communication delay requires a more strategic and patient approach. Every command must be meticulously crafted to address the known issues without causing additional problems, considering the extended time it will take to confirm whether the command had the desired impact. The critical communication delay also means that the engineering team has limited opportunities to interact with the spacecraft. Each command sent must be effective and precise, leaving little room for error. This requires extensive testing and validation of commands on Earth before they are sent to Explorer 1. Moreover, these logistical difficulties are compounded by the fact that the spacecraft itself is over 40 years old, having been launched in 1977. The technology on board, although state-of-the-art at the time, is now considered outdated by modern standards. The engineering team must work with hardware and systems that were designed and built in the 1970s, adding another layer of complexity to the problem-solving process. The harsh space environment also takes a toll on the spacecraft systems. Explorer 1 has been exposed to cosmic radiation, extreme temperatures, and micrometeoroids for over 45 years. These factors contribute to the wear and degradation of its components, making it even more challenging to maintain and repair. Despite these obstacles, the engineering team remains committed to resolving the issues. They are investigating various theories about what may be causing the anomalies and testing possible solutions through simulations on Earth. This careful, deliberate approach is essential given the stakes involved. Any incorrect command could potentially worsen the situation or lead to a loss of communication with the spacecraft. The team is also utilizing the redundancy built into Explorer 1's systems. Like many space missions, Explorer 1 was designed with backup systems to increase its resilience to failures. The engineering team may be able to switch to these backup systems or reconfigure existing components to bypass the malfunctioning parts. NASA said in another statement that until the cause of the issue is better understood, the team cannot predict how long the spacecraft will be able to collect and send scientific data. Nevertheless, Susan D. and the engineering team are confident that the issue will be addressed. If it's something that can be fixed with the antenna, which controls the spacecraft's orientation and communication, it would still be difficult to believe there was a significant problem to address. Issues we currently face have been promptly disproved by researchers. Explorer's capacity to work depends heavily on the antenna's attitude and communication control system. For starters, it generally keeps its antenna focused on Earth so that researchers can accurately receive information. Moreover, it controls how the spacecraft is oriented. Engineers monitoring the situation now feel that the antenna is working as it should, which only adds to the conundrum we currently face. Additionally, none of the safety features designed to protect the spacecraft from danger have been activated. Susan D., project manager for Explorer 1 and 2, notes that a mystery like this is not unusual at this stage in the mission. The shuttles are both around 45 years old, which is significantly older than what was anticipated in the mission plan. Susan D. also acknowledges that the spacecraft's engineering team will face significant challenges in resolving the issue with Explorer 1 due to the distance between us and the spacecraft. The difficulties are considerable, largely due to the spacecraft being around 145 billion miles from Earth. Explorer is sending back alarming information to Earth. Explorer 1, NASA's farthest voyaged shuttle, continues to travel across unseen regions of the universe nearly 50 years after its launch. Researchers are puzzled by the disturbing data that this well-known space probe is transmitting back to Earth due to what appears to be a glitch. The mysterious signals sent back from Explorer during its extended space journey have raised concerns and questions among scientists. The quest to understand the universe's origins since the Big Bang inspired the launch of Explorer 1 and its twin, Explorer 2, among other space missions. Explorer 2 was actually the first to launch, departing from NASA's Kennedy Space Center on August 21, 1977. Explorer 1 followed about 2 weeks later, on September 5, 1977. The two spacecraft, despite their similarities, had to travel at different speeds and in different directions. Explorer 1 managed to pass its twin on December 15, 1977, and has since been a valuable resource for uncovering cosmic mysteries. The first major mission of Explorer 1 was the Jovian imaging mission in 1978. At that time, the spacecraft was around 265 million kilometers from Earth and sent a wealth of images back to us. It completed an impressive 100-hour mission starting in January 1979, during which it captured 3,750 images of Jupiter's rotation, creating a time-lapse film that showed 10 of the planet's rotations. By February 1979, Explorer 1 had flown through Jupiter's moon system and, a month later, observed Jupiter's faint ring. It also made significant discoveries, including finding 2 new moons, named Steele and Meide. Efforts were made to ensure that the spacecraft was prepared for its flyby of Saturn and to avoid a potential collision with Titan, one of Saturn's moons. During its orbit of Saturn, Explorer 1 discovered 4 additional moons, including Mimas, Enceladus, and Dione. After completing the Saturn mission, the decision was made to halt the planetary mission and send both Explorer 1 and Explorer 2 beyond the solar system at a rate of 325 million kilometers per year. In January 1990, the new mission, known as the Explorer Interstellar Mission, began. On February 14, 1990, Explorer 1 captured some of the most famous images in history, depicting the Sun and most of the planets from a distance of 6 billion kilometers. These images are often referred to as the family portrait of the solar system. A total of 60 images were taken, bringing the total number of photographs from the spacecraft to 670. Despite the fact that Mercury and Mars were not visible in the images due to various factors, the spacecraft's cameras were eventually turned off to conserve power and memory before its journey into interstellar space. In addition to the interstellar missions of Explorer 1 and 2, NASA also operated the Pioneer 10, Pioneer 11, and New Horizons spacecraft. Before Explorer 1, Pioneer 10 was the furthest spacecraft, having been launched on February 17, 1978. Explorer 1 continued its journey for another 14 years before entering interstellar space on August 25, 2012. NASA did not publicly announce this achievement until 2013. By November 2018, both spacecraft had officially left the solar system. Explorer 2 crossed the heliopause and entered the interstellar medium, while Explorer 1 was reported to be 145 billion kilometers or 1,550 Australian dollars from Earth. It has continued to provide valuable data from the far reaches of the solar system and beyond. Recently, however, there have been troubling developments. The spacecraft is now sending back enigmatic signals to Earth, suggesting it may be uncertain of its location coordinates. Typically, Explorer would have been programmed to enter safe mode or alert researchers if it became lost in space. Despite this, its antenna, which transmits data back to Earth, appears to be functioning correctly. Nevertheless, the data being transmitted recently has been peculiar. The spacecraft is functioning normally, receiving commands from Earth and executing them, but the readouts from its systems do not accurately reflect its condition. According to a NASA statement, the exact cause of these anomalies is not yet clear. Each spacecraft, including Explorer 1 and 2, has a 12-inch gold-plated disc with sound and video messages for potential extraterrestrial beings. This disc contains various Earth sounds, 115 life images, 90 minutes of Western music, and greetings from former U.S. President Jimmy Carter and former UN Secretary-General Kurt Waldheim, among other items. The disc is designed to provide a snapshot of Earth's civilization should the spacecraft be discovered by extraterrestrials. However, researchers have quickly ruled out the possibility that the spacecraft is under extraterrestrial control. Explorer's functionality relies heavily on its attitude and communication control systems. It usually keeps its antenna pointed at Earth to ensure accurate data transmission and controls the spacecraft's orientation. Engineers monitoring the situation now believe that the antenna is working correctly, which adds to the confusion. None of the safety features designed to protect the spacecraft have been activated. Susan D., the project manager for Explorer 1 and 2, notes that such mysteries are not unusual at this stage in the mission, given the spacecraft's age of around 45 years, which exceeds what was initially anticipated. She also acknowledges the significant challenges faced by the engineering team due to the spacecraft's vast distance from Earth. The spacecraft is approximately 145 billion miles away, presenting considerable difficulties in resolving the issue. The immense distance complicates the situation further. A salvage operation is nearly impossible with current technology and logistics. The spacecraft's journey has taken it into the farthest regions of the solar system and beyond, where it continues to travel away from Earth. Messages sent from Earth to Explorer 1 travel at the speed of light, requiring nearly 21 hours to reach the spacecraft. This delay makes it challenging to issue timely commands or troubleshoot issues. Any command or guidance sent requires about 2 days for round-trip communication. This extended delay necessitates a careful and strategic approach to command design, as engineers must anticipate various scenarios and potential outcomes. The long communication delay means that every command must be precise and effective, leaving little room for error. Compounding the issue is the spacecraft's age. Launched in 1977, the technology on board is outdated by modern standards. Engineers must work with systems and hardware from the 1970s, adding to the complexity of problem-solving. The harsh space environment, with exposure to cosmic radiation, extreme temperatures, and micrometeoroids, has also contributed to wear and degradation of the spacecraft's components. Despite these challenges, the engineering team remains committed to resolving the issues. They are investigating possible causes and testing solutions through simulations on Earth. This meticulous approach is crucial given the stakes involved. Any incorrect command could worsen the situation or lead to a loss of communication. The team is also utilizing the spacecraft's backup systems, designed to increase resilience. Although the spacecraft's engineering team faces significant challenges, they remain hopeful and are working